Okay, so to answer the question that we were trying to do on the PES, in general, ionization energy increases as you go across, decreases as you go down. But we're seeing in the data that for something like sulfur and phosphorus, there is a discrepancy. So phosphorus should have, phosphorus has how many protons? 15. And sulfur has 16, right? Okay. Oops. That doesn't look right. Sulfur has 16 protons. Okay. So sulfur should have a higher first ionization energy than phosphorus, but it doesn't. What is a possible explanation? When you're being asked to explain either a normal trend or a discrepancy in a trend, you have several tools that you can use. One of the tools that I always start with is electron configuration. So phosphorus is 1s2, 2s2, 2p6, 3s2, 3p3, correct? And sulfur is very similar, but instead of 3p3, it ends in 3p4. Okay, so I look at that and see if that sheds any light on it. And just by itself, no, not really. So now I'm going to kind of go deeper and I'm going to look at the orbital diagram. And I really want to only look at the orbital diagram for the valence shell. Okay, so this S has 2 electrons in it and the P has 1, 2, 3. This has 2 electrons in it and the P has 1, 2, 3, 4. Okay? Now, why did I fill it up by going up, up, up instead of up, down, up? Hund's rule. Okay? Why is Hund's rule a rule?
Because electrons want to spread out.
Okay, electrons want to spread out. Now, what we need to do is we need to graduate to like an energy reason. So, tell me, if electrons are wanting to spread out, what's the energy reason they're trying to do that?
They want the lowest energy configuration.
They want the lowest energy configuration. Why does getting far apart minimize their energy?
Because when they're closer, they repel, and
there's less repulsion. So, spreading out minimizes electron repulsion. It's a great thing to write down. Okay? And therefore minimizes the energy. So electron repulsion, we talked about this. Spreading out electrons minimizes electron repulsion. Okay? So guys, let me ask you this. The 3 S's are identical, but the 3 P's are different. Which one has more electron repulsion?
S.
This one does. So guess what? This is actually a slightly less stable configuration of the electrons because it's experiencing some repulsion. So actually, it's a little bit easier to remove one electron from here, because if an electron is removed, now you have minimized electron repulsion. Here, removing an electron doesn't do any of that. Okay? Removing an electron doesn't minimize the electron repulsion. Just shift over a little bit. Okay? But here, removing this electron does minimize the electron repulsion. And so that is why we think the ionization energy for sulfur, instead of being higher, because as you go across, it's usually going higher, that's why we think it dips. Because by removing this electron right here, you are minimizing the electron repulsion and therefore making it more energetically favorable.
That's pretty cool.
Yep. Your turn.